Welcome to Top Notch Online TV, the ocean of knowledge. You are with me, teacher Thaddeus Mbaluka, your chemistry mentor and a certified working chemical. Today I want to navigate through the Octopus revision for sulfur and its compound. As I told you in my previous Zoom meeting, remember I told you that these are the kind of notes that you'll need when you are waiting for KCSE. So we'll be able to summarize the entire sulfur and its compound. 30 lessons in just using one page. So we start by looking at sulfur, and we look at the extraction of sulfur using the Frasch process. Under Frasch process, we have three concentric pipes. First of all, we have the outermost pipe, which contains the superheated water. We have the outermost pipe containing the superheated water, whose role is to melt the sulfur. So here you need to know the three concentric pipes from the outermost, the innermost pipe, and the middle pipe. What do they contain and what the role of the components? Then we have the middle pipe. The middle pipe is the one that conveys the molten sulfur and water to the surface. Remember, we have the innermost pipe contains hot compressed air, and don't say compressed air, it is hot compressed air. That whose role is to force the molten sulfur out, and it is the molten sulfur plus water which is forced out through the middle pipe. So in that kind of a scenario, by looking at that analysis, you can simply be able to know what are the role of each of the components that are passing through different pipes. So the other one is now what the sulfur and water, the molten sulfur and out is now forced out to the surface, to the collecting tanks. They can be separated simply because sulfur is insoluble in water. So if you talk about sulfur being insoluble in water, then you're going to have two layers. The layer of sulfur and the layer of water, which now can be easily be separated. And then you're also going to be asked what properties of sulfur that makes it possible to be extracted through the Frasch process. Sulfur has a low melting point and is insoluble in water. And sulfur does not also react with water. Remember, the property of sulfur being insoluble in water or does not react with water is what makes it possible to be extracted through the Frasch process. Because if it was soluble in water, then you're going to have a uniform mixture of sulfur and water, and therefore it will be very difficult to separate them. Then we have the allotropes of sulfur. Also make sure that you look at them. Make sure that you know how to draw each of them. The rhobic and monoclinic sulfur. No, the transition temperature is 96. That below 96, it is rhobic sulfur that is stable, while above 96, it is a monoclinic sulfur which is stable at that particular temperature. So somebody can simply ask you which allotrope of sulfur is stable at 25 degrees Celsius. The examiner may not necessarily mention 96 degrees Celsius, but can mention any temperature below 96, like a temperature of 25. So if you're told what temperature of what allotrope of sulfur is stable below, or rather at 25 degrees Celsius, just say that is rhobic, because 25 is below 96. Then we also need to know what is the meaning of an allotrope. Allotropes are different crystalline forms of an element in the same physical state. Different crystalline forms of the same element in the same physical state. Remember that allotropes have a particular shape. Then we have the chemical properties of sulfur. It's very easy. using the Octopus technique, we can look at burning sulfur, combustion. Sulfur burns in air with a blue flame to form sulfur 4 oxide. Sulfur burns in air with a blue flame to form sulfur 4 oxide. Sulfur will react with metals to form the corresponding metal sulfide. Like sulfur with magnesium, you get magnesium sulfide, which is white. Sulfur with copper, you get copper sulfide, which is black. Sulfur with iron, you get iron 2 sulfide, which is also black. Then we have sulfur reacting with the concentrated acid. Sulfur will react with concentrated sulfuric 6 acid and will also react with concentrated nitric 5 acid. Sulfur reacts with concentrated sulfuric 6 acid to form sulfur 4 oxide plus water. Then you can be told what are the observations when concentrated sulfuric 6 acid is added to sulfur. Then you're going to say the yellow solid dissolves because sulfur is yellow. Then there are bubbles of a gas. The gas is sulfur 4 oxide. With the nitric 5 acid, we are going to get sulfuric 6 acid plus nitrogen 4 oxide plus water. Then what are the observations when you add concentrated nitric 5 acid into sulfur? The yellow solid dissolves. There are bubbles of a brown gas. Then we also need to look at what are the uses of sulfur. Sulfur is used in manufacture of sulfur drugs. Sulfur is used in manufacture of sulfuric acid, manufacture of gunpowder, matchsticks, insecticides, and fungicides. Calcium hydrogen sulfide is also made from sulfur, which is a bleaching agent in the paper industry, and sulfur is also used in vulcanization of rubber. Then from there we now go to just here before I forget that very important thing. Somebody will ask you why sulfur does not react with dilute hydrochloric or concentrated hydrochloric acid. Hydrochloric acid is not an oxidizing agent, therefore it cannot react with sulfur. And also sulfur is below hydrogen in the reactive series, therefore cannot displace hydrogen from an acid. So sulfur does not react with both dilute and concentrated hydrochloric acid. Reaction of sulfur with concentrated acid is not a displacement reaction, but it is a redox reaction. Then we have sulfur 4 oxide now. We are now through with sulfur. We go to the East oxides. So we start with sulfur 4 oxide. Sulfur 4 oxide, we start with the laboratory preparation. There are two methods in which sulfur 4 oxide can be prepared in the laboratory. And we have copper plus concentrated sulfuric 6 acid, whereby you get copper sulfate plus sulfur 4 oxide plus water. Remember what observations are made in the flask. The brown solid dissolves and there are bubbles of a gas, and also there is a blue solution due to the copper 2 sulfate formed. Then we have now sulfur reacting with, we have now sulfur reacting with, we have now the other method of now preparing sulfur 4 oxide, which is now sodium sulfate reacting with either dilute HCl or dilute sulfuric 6 acid. We having the other method of preparing sulfur 4 oxide is use of sodium sulfide reacting with dilute acid, that is dilute HCl, and sulfuric 6 acid, or rather dilute sulfuric 6 acid, whereby the product are sodium chloride plus sulfur 4 oxide plus water. Once now the sulfur 4 oxide is prepared, it is passed through concentrated sulfuric 6 acid to dry the gas and collected by downward delivery. If you want to prepare a solution of sulfur 4 oxide, you can use an inverted funnel. The role of the inverted funnel is to provide a large surface area for the dissolution of the gas and also to prevent sucking back. We have now prepared sulfur 4 oxide. We now go to the properties. The issues of physical properties, you can just remember them. Very soluble in water. It's also denser than air. And it also has a pungent smell. Then we go to the chemical properties of sulfur 4 oxide. We start with how does it react with water. Sulfur 4 oxide reacts with water to form sulfuric 4 acid. And I want you students to listen to this. This question is very common in exams. And many students will say instead of sulfuric 4, they'll say sulfuric 6. So sulfur 4 oxide dissolves in water to form sulfuric 4 acid. Not sulfuric 6. You get sulfuric 4 acid. Now, in that kind of a scenario, we have now, this is what makes it to be able to change blue litmus paper red then white. So that is what explains the bleaching and acidic properties of sulfur 4 oxide. So when you have sulfuric 4 acid with dye, the dye will release oxygen. Rather, sulfuric 4 acid will remove oxygen from the dye, forming sulfuric 6 acid. The sulfuric 4 acid will remove oxygen from the dye, forming sulfuric 6 acid, and therefore the dye is bleached. So that's why we say sulfur 4 oxide bleaches by reduction, because it removes the oxygen from the dye. It is now different from that of chlorine, which bleaches by oxidation, by adding oxygen to the dye. Remember, chlorine is an oxidizing agent, so it bleaches by oxidation, by giving oxygen to the dye. But sulfur 4 oxide is a reducing agent, so it removes oxygen from the dye, and therefore the dye is bleached. And bleaching by sulfur 4 oxide is temporarily, because on exposure to the air, it is going to regain the oxygen that was lost, and therefore it is going to regain its color. And that's why old newspapers will turn yellow after some time, because they are able to gain oxygen from the atmosphere, and the dye regains their original color. We go to reducing sulfur 4 oxide as a reducing agent. When you bubble it through purple acidified potassium manganate 7, the purple acidified potassium manganate 7 changes to color, because the oxidation state of manganese changes from 7 to positive 2, from positive 7 to positive 2, and that is why it changes from purple to colorless. When you bubble sulfur 4 oxide through acidified potassium dichromate 6, it changes from orange to green, because the oxidation state of chromium changes from positive 6 to positive 3. Then we have bromine water, which is yellow. Bromine water, which is yellow, it is reduced by sulfur 4 oxide to hydrobromic acid, which is colorless. And the change in color with manganate 7, potassium dichromate 6, and the use of bromine water is the chemical test for sulfur 4 oxide. So when you're told to describe a chemical test for sulfur 4 oxide, you're going to say bubble sulfur 4 oxide through purple acidified potassium manganate 7. It will change from purple to colorless. Bubble sulfur 4 oxide gas through acidified potassium dichromate 6. It changes from orange to green. Then we also have, you can pack the gas, or rather bubble the gas through a solution of iron 3, which is yellow. It will change to green, because the iron 3 which is yellow is reduced to iron 2, which is green. Then we have reaction with sodium hydroxide. When you bubble sulfur 4 oxide through sodium hydroxide, you get sodium sulfide plus water. But when you bubble excess sulfur 4 oxide, then you get sodium hydrogen sulfide. And that's how an examiner will tell you, describe how you can obtain sodium hydrogen sulfide starting with sodium metal. That's the concept of salt. Then you're going to say, dissolve sodium metal in water to get sodium hydroxide. Then you bubble excess sulfur oxide to get sodium hydrogen sulfide. Then you go to oxidizing property. Sulfur oxide is an oxidizing agent. If you lower a burning magnesium into a gas jar full of sulfur oxide, it continues to burn, forming a mixture of a white solid and a yellow solid. So when you burn, when the heat produced by a burning magnesium will be able to decompose sulfur oxide into sulfur and oxygen, and it is the oxygen that supports the burning magnesium, therefore forming magnesium oxide and sulfur solid. Therefore, magnesium oxide is white solid and sulfur is as a yellow solid. So that is why when you lower a burning magnesium into gas jar full of carbon dioxide, you get magnesium oxide and sulfur. Then we have passing sulfur oxide, you react it. You can now invert a gas jar containing sulfur oxide over another gas jar containing hydrogen sulfide. The gases must be moist. Then you get sulfur and water. In those instances, the sulfur here will act as a oxidizing agent. It will be sulfur in this point. It will be the oxidizing agent, or rather, because it's going to be reduced. Remember, an oxidizing agent is always reduced. So its oxidation state will reduce from positive 4 in sulfur oxide to 0 in sulfur. Therefore, it is being reduced. So sulfur oxide is normally a reducing agent, but hydrogen sulfide is a stronger reducing agent. So when they combine, sulfur will be the oxidizing agent, while hydrogen sulfide will be the reducing agent. Then you can go to uses of sulfur oxide used in manufacture of sulfuric acid, manufacture of sulfides and hydrogen sulfide. Also refining kerosene and other petroleum products, for reviving and decolorizing sugar, as a disinfectant, as a fumigant, firstly to fumigate greenhouses, solvent for glue, refrigerant in household refrigerators, and as a preservative for wines, meat, fruits. So you can talk about now what the use of that's why sulfur oxide can be used in fruit juices as a preservative. Then the other one we have now, the hydrogen sulfide again. Hydrogen sulfide preparation, we normally use iron 2 sulfate plus dilute HCl. We can also use copper sulfide or zinc sulfide plus dilute HCl, whereby you get a green solution plus hydrogen sulfide. The black solid, the observation that will be made in the conical flask will be the black solid dissolves. That is now the iron 2 sulfide. There are bubbles of a gas with a pungent smell, and then the gas is collected over warm water. But if needed dry, it is collected by downward delivery because it is denser than air. Chemical properties, they are the same. Remember, we don't have to repeat again. The reducing property are the same of that sulfur oxide, but in hydrogen sulfide, a yellow deposit of sulfur is seen. So if you are told what observation is meant when you bubble hydrogen sulfide through acidified potassium manganate 7, you're going to say the purple acidified potassium manganate 7 changes to colorless and a yellow solid is deposited. So here, the observation will just be the same. But in addition to the observation that was meant when you're using sulfur oxide, like the use of acidified potassium, dark chromatic, again, it will change from orange to green, but also yellow solid is deposited. When you pass it over bromine water, the yellow bromine water changes to colors, but again, a yellow solid is deposited. Remember, in the laboratory, hydrogen sulfide acts as a reagent to detect the presence of certain metal cations. Normally, possibly we have the use of when you bubble hydrogen sulfide through lead nitrate, you get a black precipitate. So it can be used like that. Hydrogen sulfide is used in the preparation of metallic sulfide. If you pass it over possibly like magnesium, you'll be able to get magnesium sulfide. Now, then we continue to conduct process whereby we are going to talk about the sulfuric acid. Sulfuric acid, we have the raw materials. The raw materials in the conduct process, we have sulfur, we also have metal sulfide, we have air, and we also have water. So, but the main ones are sulfur or metal sulfide, then we have air. Then the conditions are temperature 450 degrees Celsius and 2 to 3 atmospheres. Then we have vanadium 5 oxide as a catalyst, but you can also use platinum. But we preferably use vanadium 5 oxide because it is cheaper and not easily poisoned by impurities. The main reactions in manufacture of sulfuric acid, we first of all have the reaction in the roaster, whereby we have, these are where we obtain sulfur oxide. So we burn sulfur in air to get sulfur oxide. We can also burn metal sulfide, like zinc sulfide in air to form zinc oxide plus sulfur oxide. Purification chamber to remove impurities like carbon dioxide and dust impurities. Then we have the drying tower. The drying tower is to dry the gases. Then we have the compressor. The gaseous mixture is compressed to the required pressure of 2 to 3 atmospheres. Then heat exchanger. The gaseous mixture is heated to the correct temperature, which is 450. Then from there we go to the catalytic chamber, whereby the sulfur 4 oxide will react with oxygen to form sulfur 6 oxide. This reaction occurs in presence of vanadium 5 oxide. The temperature maintained at 450 and pressure of 2 or 3 atmospheres. Remember, if you are told to give the conditions, don't say pressure of 2 to 3. Just tell us a pressure of 2, or you can give 3 atmospheres. From there, after sulfur 6 oxide is formed, it is now dissolved in concentrated sulfuric acid in the absorption chamber to form oleum. In the absorption chamber, we have sulfur 6 oxide being dissolved in conc sulfuric acid to form oleum. Then sulfur 6 oxide, remember, is not directly dissolved in water because the reaction is highly exothermic, leading to formation of harmful acid fumes. So that is why we don't dissolve it in water, although you can simply dissolve sulfur 6 oxide in water to get sulfuric acid, but not dissolved in water because this leads to formation of oleum. Or rather, this we are saying when you dissolve sulfur 6 oxide in water, you get harmful acid droplet because the reaction is highly exothermic. So the best way to dissolve sulfur 6 oxide is to dissolve it first in concentrated sulfuric acid to form oleum. Once you form the oleum, now the oleum is carefully diluted with controlled amount of water to form 98% concentrated sulfuric acid. Remember, there are two things there. There are two precautions there. That you cannot dissolve sulfur 6 oxide in water because the reaction is highly exothermic, leading to formation of harmful acid droplets. Number two, in the dilution chamber, whereby we are diluting oleum, there's a missing 7 there, whereby we are diluting oleum. Here we have oleum there is 7. We have letter 7 there. That oleum is H2S2O7. Oleum is H2S2O7. Oleum is H2S2O7. Then it is carefully diluted with water to get concentrated sulfuric acid. Then we have said the precaution there. It is carefully diluted with water, because if you add a lot of water, you'll end up getting now very dilute sulfuric acid. Then we have the reaction, the scrubber. Then we are talking about now that during contact process, the main pollution is due to the use of sulfur oxide. That's due to the release of sulfur oxide. So sulfur oxide is the main pollutant that is released in the contact process. And how can pollution be controlled? Pollution can be controlled by use of scrubbing, whereby as the scrubber we have calcium hydroxide react with sulfur oxide to form calcium sulfide plus water. So you can be told to write reaction the scrubber. We have calcium hydroxide reacting with sulfur oxide to form calcium sulfide plus water. That is one method of controlling pollution. We have other two methods. The other two methods of controlling pollution is recycling. You recycle the sulfur oxide. The unreacted sulfur oxide is not released but can be recycled. Then we have the FGD, which is called the flue gas desulfurization device. The use of the flue gas desulfurization device, FGD. Then that is the summary of contact process. Main reaction occurs in the roaster. Sulfur oxide reacts with oxygen to form sulfur oxide. The other one occurs the catalytic chamber, whereby we have the sulfur oxide react with oxygen to form sulfur 6 oxide. Then we have the sulfur 6 oxide being dissolved in concentrated sulfuric acid to form oleum. Then we have the oleum being diluted with water to form concentrated sulfuric acid. And then we have finally the reaction, the scrubber, whereby we having the calcium hydroxide react with sulfur oxide to form calcium sulfide plus water. Then finally, the other gas that I have not handled is the laboratory preparation of sulfur 6 oxide. The sulfur 6 oxide is prepared by reacting sulfur oxide gas with oxygen gas. This is the only gas that whose reagents are only gaseous reagents, and is collected. Is now, remember, you particle of a plastic and asbestos. Sulfur oxide cannot react with oxygen except in presence of a catalyst to prepare to obtain sulfur oxide. Once it is obtained, it is now directed into a freezing mixture, whereby it is collected as a solid. We are going to have the sulfur 6 oxide crystal. So sulfur 6 oxide is the only gas that is collected as a solid. Now, why is it collected as a solid? Sulfur 6 oxide has a high affinity for water. In gaseous state, the intermolecular forces, the intermolecular spaces are wide and readily absorb water and change to fumes of sulfuric acid. In solid state, the ability to absorb water is minimized due to the close packing of the particles, or rather of the molecules, and or rather due to the compactness of the particles, and hence it is more stable. As the other method of preparing sulfur oxide is by eating iron 2 sulfate. You can eat hydrated iron 2 sulfate. We talk about iron 2 sulfate heptahydrate because it has 7 moles of water. And when it's heated, you get iron 2 sulfate plus water. Then the iron 2 sulfate is now further heated to form iron 3 oxide plus sulfur oxide plus sulfur 6 oxide. That is now the other method of preparing sulfur 6 oxide. And students, we have come to the end of a beautiful lesson today, whereby I was unpacking the topic of sulfur and its compound using the undisputed Octopus technique. Keep it here at Top Notch Online TV, the ocean of knowledge. And also for your young brothers and sisters, let them also subscribe to Top Notch Kids, whereby they are going to get one of the most distilled and refined content in the entire world. Thank you until next time. Bye bye.